My name is Florian Wenzel, and I'm from the University of Augsburg. So I'm more from the research direction, but today I want to talk about the application side. I want to talk about personalized search in location-based services and in map applications. Especially I want to talk about the drawbacks of current approaches, and then I want to present our research prototype Preference SQL system, which takes care of some of the problems and tries to fix them. So as I said, I'll start off with the drawbacks. Mostly what we see with basic filtering approaches that we either run into flooding or in empty results. If we have a search and it's just doing a radius search, this is Google Local on an Android phone, and I'm just looking for restaurants somewhere in my hometown. There's lots of points popping up, and I don't know which one I should choose. If I narrow down the search, this is another application, and I filter it one by one, given the axis or the dimensions. Then suddenly I get no results for bars because I'm too specific in my search. So I have a perfect understanding of what I'm looking for. I can narrow it down to certain dimensions, but the app doesn't give me the best alternatives. It just does hard filtering. So how should I get the best alternatives? If I'm looking for hotels in a certain city district that have a certain price, maybe I'm also interested in alternatives that are close by, but and have that specific price, and I'm willing to take this drawback into account. Next one is that whenever I'm looking for spatial content, that most applications just give me points nearby. So that's all I can search for, points nearby my current location. And it's basically all apps that are doing this. But if I want to have some other specific preferences, if I have 2 or 3 points that I want to have my restaurant or my hotel to be close by, or if I want to have points that I don't want to be close. The same with polygons. Maybe there are some areas within a city that I want to live in and others that I want to avoid. Or line strings, parts of the streets that I like and parts that I want to avoid, and so on. So these are all really restrictions that we have so far in current location-based services that don't let the user express their real preferences. Yeah. Then the next one is that whenever I do radius search, basically that's what I'm getting. I get these concentric circles around my current location, and it doesn't take into account the street network or whatever transportation mode I'm on. So I'm running into this problem. I get results on the other side of the river, and they're just taking the Euclidean distance. That's a perfectly fine match. Taking routing distance, so this one should not be into my result set. So how can we modify location-based search to get routing distance as a measure? Next thing, all applications just offer results for one user. I think that's perfectly fine when you look at mobile applications, but if you have map applications, maybe you're going on a trip with a friend, colleague, whoever, and we want to have a shared hotel, and everybody has its own preferences, and we want to find a good compromise for both of them. So whatever application you're looking at, it's just one user center, and it doesn't give you support for multiple users, as you can see on the right-hand side. So these are all the drawbacks. On the left-hand side, I told you about my wishes, or on the right-hand side. So what did we do? Well, we augment classical search, which is mostly done via SQL and hard constraints, and we added another feature that allows to express soft constraints, and this opens up the possibilities for alternatives. So instead of doing exact search, we're doing more like a similarity search. We got all these dimensions, and as somebody mentioned in the Q&A earlier, We just try to be close in every dimension, and maybe we're better in one dimension, worse in another, but we still give the user some kind of alternatives. So we're replacing exact match with best match. The other side is, I talked about the query model. We're allowing KML as queried. So I can say I want to live, or I want search results within a certain area, and I just pass this area as KML within my search query. So basically I can search using any kind of geometry. Next thing is, if I'm looking for objects that are close by, I can use routing distance now. So similarity is not only based on Euclidean distance, but it's also based on routing distance, which avoids the problem we saw earlier with the hotel on the other side of the river. And of course, we can, in these queries, we can combine wishes of multiple users into one search query, and we get best results for a whole group of users. And then they can figure out which one is the best compromise. So what's the current state right now? On one side, we got our research prototype that we're using in projects with industry. It's a Java middleware, and you just plug it in between your application and your database, so you don't have to do any modifications on the database. You just get an extended query language, and then you just need to adapt your application so that it generates these new queries. And on the other side, we got, since Java is not the best option for a commercial product, we got another cooperation with a database company, and they're implementing the functionality in their database system. So basically, how can you use it in your application? I'll also show you a short demo movie while taking questions so that you have an impression on how this system works. You get your application. The application is generating some search query as you would normally with hard constraints. It's transferred via JDBC to the server. We just parse the query, we evaluate it, taking the data from the database on the right-hand side. And all that we did is we just leave the query syntax so that you know from SQL, and we enhance it with this preferring clause. And within this clause, you just mention your preferences, and then these are evaluated with soft constraints instead of hard constraints. So that's basically it. And it works in any database, any spatially enabled database. You can use it with Oracle Spatial, you can use it with Postgres, you can use it MySQL, or probably any database, relational database that you want to use at that. So just to give you a few examples, I think that's kind of boring, but just to see how this syntax looks like. Here we're looking for locations so that are nearby a certain coordinates, and we can also combine this with other wishes. And we can say, okay, this wish is more important than another wish, and then we use this prior to connector. Or we say wishes are equally important, and then we use this and connector. And that's how certain wishes are traded off against each other, and that's how the final results are calculated. That's the same thing here. We see how we can search within a certain polygon. We just pass the KML of the polygon. This is looking for results at a certain part of the street. We can also have preferences in other dimensions like the price. We want to have the lowest price, the highest price around a certain number or whatever. Yeah. So I want to present a showcase that we did for a database conference. You can also check it out online. You need a user and a password. It's called GeoMonday. If anybody's interested, just take a look. Basically, it's a search application based on the Preference SQL system, which lets you draw certain overlays on a map, and you find hotels in Istanbul. And you can also use the group feature and try to find a hotel that's best for a group of users. Yeah, there's some contact information if you want to know more about the system. And I think I'll stop the movie and then I'll take some questions.